If you've ever decided to dive into a truly functional language like Haskell, you realize pretty quickly it's not just a new syntax you're confronting.
Oh, not at all.
It's like learning a foreign architectural language, full of these foundational ideas and patterns you just don't see anywhere else.
Right.
And that initial hurdle, that moment you try to figure out how a simple program actually builds, that can just stop you cold.
And that's precisely why we loved the methodology in our source material for today. We're drawing from part 17 of our programming series on keynmmeng.org.
Okay.
And their technique isn't just, here's some code. It's this deep, methodical deconstruction of every single line. They treat AI almost like a sparring partner, or as they put it, a glorified rubber duck.
A rubber duck, I like that. It provides the context that you just lose in those high-level tutorials.
It does, and that deep context is what you're here for. We're not skimming the surface.
No, we're using this method to get a really deep understanding, but without the information overload you get from reading endless documentation. We're just pulling out the core nuggets.
So our mission today is to do a bit of an archaeological dig into a new Haskell project. We're analyzing that foundational structure.
Specifically, the build process.
Exactly. Which, in functional programming, is often where the real magic and the real complexity is hiding. We're zooming right in on this seemingly tiny file, Setup.hs.
Right. So the source material kicks things off, as most Haskell projects do, by creating a sample project called xtef2book.
Using the command stack, new SS2 ebook.
And for anyone new to this, that command immediately brings up the whole complexity of the Haskell toolchain. You've got stack, Cabal, GHC, all working together. So before we even look at the file, let's map out that hierarchy.
That's essential context. So think of Stack as the heavy machinery. It's the high-level project manager doing package creation, dependency solving, all that stuff.
Okay, so Stack is driving the project.
It is. But what engine is Stack actually running? That's Cabal. Cabal is Haskell's primary fundamental build system.
So Stack manages the whole environment and calls the shots, but Cabal is the one on the ground actually doing the compiling and linking.
Precisely. Cabal is the specialized lower-level engine, and where Setup.hs fits in? Well, historically, Setup.hs was the handwritten instruction manual for that Cabal engine.
It told Cabal exactly what to do.
Exactly. Even though modern Stack and Cabal have these, sophisticated default behaviors, Stack still generates that file. It gives you a clean slate for customization or, in our case, for a little bit of historical analysis.
Okay, that frames our inspection perfectly. We're looking at the core files you get from that initial stack new command.
Right.
You get your main executable logic in appmain.hs, your library code in, clib.hs, your tests in testspec.hs.
And then there's setup.hs, just sitting there in the project root.
That setup.hs file is a direct nod to the history of the Haskell build process then. For years, it was the non-negotiable entry point for Cabal.
It dictated every single step.
So if Cabal and Stack are smart enough now to figure out the build steps without this file, why does the tooling still generate it? Is it just academic?
It's not purely academic, though it does serve as a historical marker. It's really there for legacy support and for when you need truly custom build logic.
Like what?
Say, integrating C libraries or doing some complex pre-processing steps. If you need to break the mold, you edit this file. If you don't, it just sits there silently running the defaults.
So it's the programmer's failsafe, the point of maximum control.
That's a great way to put it.
A point of maximum control that, in its default state, is remarkably short. But before we get to the lines, I want to acknowledge a key part of the author's methodology.
The NL utility.
Yes, a line numbering tool with a very specific alias. Alias NL, NL9W1BASS.
And that might sound like a tiny technical detail, but it reinforces the core principle of studying a language like Haskell.
How?
In Haskell, every single character, every line has real significance. The author's meticulousness there, just setting up a clean way to reference line numbers. It shows the dedication you need to really internalize a language where nuance is everything.
Especially when the instruction manual we're looking at is only 2 relevant lines long.
You have to treat those 2 lines like sacred text.
Agreed. Let's look at the script. The default setup.hs. It's deceptively brief. There are just 2 lines that define the entire default build process.
Line 1, import distribution, temple.
And line 2, main is default main.
That's it.
2 lines. To handle dependencies, configuration, compilation, my programmer intuition is screaming.
Yeah.
If it looks too simple, you've missed a mountain of complexity it's hiding.
And your intuition is 100% correct. Let's start with line 1. Import distribution, simple. This is bringing in a module from the Cabal library.
Okay.
And this module is the engine for what's called the simple build system.
Simple. So the name implies it's easy to use, but what does the source material say about how it actually works inside?
This is a classic case of programmer misdirection, and the documentation analysis in the source really highlights it.
Okay.
The simple label does not refer to the module's internal complexity, which is, in fact, incredibly high. It's dealing with platform-specific code, dependency graphs. It's a mess.
So what does simple refer to then?
It refers to the resulting complexity for you, the application developer.
Ah.
Think about it like this. Imagine trying to build a complex machine, like an old-fashioned clock. You'd need specialized tools, knowledge of metallurgy. It's incredibly complex. That's what distribution simple is wrestling with.
Okay, so then?
Now imagine you just buy a modern digital watch. You press a button and it works.
Distribution. Simple is the digital watch. It handles all the heavy lifting for me.
Precisely. The documentation confirmed this module manages all the sophisticated tasks required to build otherwise simple software packages. It abstracts away all that messiness so that your application code, your logic, can stay clean and conceptually simple.
The build system takes the complexity hit so my source files don't have to.
You got it. That is a profound piece of abstraction.
So we've established the tool that handles the complexity is imported. Let's move to line 2, main, EWL default main. What happens when the script actually runs?
Well, line 2 is the script's entry point and its entire function.
All right.
Setup.hs has to be treated as a small, standalone executable program, so it needs a launchpad. The main declaration serves that purpose, and it immediately delegates all authority to the function default main.
So default main is the actual worker function that we just imported from distribution. Simple.
That's right. Once default main takes over, it becomes the project manager. It immediately goes and reads the .cabal file.
Which has all the package, metadata, dependencies, where the files are.
All of that. And after it reads that, it just stands by, ready to execute the core build commands.
And we're talking about actions like configure, where it checks system requirements, then build, where it calls the compiler GHC, and finally install.
Exactly. And this delegation makes the manual execution steps in the source material really clear. This isn't just magic happening behind stack. It's an actual tiny program.
So you can compile it yourself.
You absolutely can. You can compile this 2-line script directly with the GHC compiler, GHC Setup.hs.
Wow.
And once it's compiled, you can run it manually. You can pass in the build instructions like setup.hs configure or setup.hs build.
It just brings everything back to first principles. It shows that even under the hood of a tool like Stack, there's a tiny little Haskell executable doing the foundational work.
And that leads us to the crucial test case the source author performed. This moves us from understanding what the code does to understanding what the compiler demands.
The programmer's eternal struggle, conciseness versus compliance. The author naturally asked, well, if default main does all the work, why can't we be minimalists?
It's a great question.
Why can't we just trim the file down to import distribution? Simple, and then on the second line, just default main. Why do we need that explicit main and creep part?
It's a completely logical thing to try. I mean, we're in a functional language. We want pure expression. But this is where the requirements of GHC, the compiler itself, they just trump that desire for minimalism.
So what happened? What happened when they tried to compile the file with just the raw default main call?
Total structural failure. Attempting to compile that 3-character shorter file with the GHC setup.hs resulted in an immediate hard stop compiler error.
This is where we need to dig in, because that error message contains the ultimate lesson here. What did GHC specifically throw back?
GHC was absolutely explicit. It spat out GHC 25277 parse error, module header, import declaration or top-level declaration expected, to default main on.
That's a real mouthful. But the message is fundamentally about structure. The compiler wasn't just confused, it couldn't even process the line.
Precisely. Let's break that error down. When GHC starts to compile a file that's meant to be a standalone executable dash and setup.hs is one, it operates under really strict rules. GHC expects to find certain structural elements. It expects a declaration at the top level, meaning a definition that binds a name to a value or a function.
And what did the author give it instead of a declaration?
They give it a raw expression. Default main by itself is just an expression. It's a function that, if you run it, would perform an action. But GHC, at the top level of an executable, it's not looking for an action to perform right now.
It's looking for a signpost, a definition it can use later.
Exactly. So when GHC reads the file, it gets to line 2, sees the unhooked expression default main, and it just doesn't recognize it as a required structural element. It's not a declaration.
By changing the line from main, default main to just default main, you've stripped away the declaration, you removed the assignment, that crucial main.
You did. The compiler needs the declaration main to name the execution hook. It's looking for a defined thing named main that tells the compiled program, start here. Without that explicit main declaration, the file just doesn't meet the basic structural requirements of an executable Haskell module.
It's a fantastic example of a rule that feels totally arbitrary until you understand the compiler's internal logic. Setup.hs is treated as a compiled binary first, and GHC imposes this strict standard for where the program's logic has to begin.
And that seemingly trivial failure validates the entire learning philosophy from the source author.
Right.
When you're dealing with a nuanced, strongly typed language like Haskell, you just can't skip the foundational blocks. Deliberately seeking out why every character is necessary, why main is non-negotiable, is the key to internalizing the language's core assumptions.
It turns arbitrary rules into deep understanding. That was a powerful journey into just 2 lines of code. We really stepped back from the convenience of stack to understand the engine underneath.
We really did a vertical slice of the build system, didn't we? From the high-level manager right down to the compiler's requirement for a single variable declaration.
Let's quickly recap our key takeaways. First, we confirmed the legacy role of Setup.hs. It's kept around for Cabal compatibility and for critical customization, even if Stack usually ignores it.
Second, we dissected those 2 lines and exposed the powerful abstraction of distribution. Simple. We learned simple doesn't refer to the module's complexity, but to its purpose, taking on the build complexity so your application can stay simple.
And finally, the critical requirement enforced by the GHC compiler itself, the function name main. It's not a convention. It is the absolute required declaration that serves as the execution hook for any standalone Haskell program.
And if you try to remove it, the compiler just fails immediately.
Now, the source material mentions that the very next step in their series is moving away from compiling setup.hs as a standalone executable and instead running the same 2 lines of code within the GHCI interactive interpreter.
Yes, GHCI.
And that distinction compilation versus interpretation raises a really essential provocative question for you to mull over. If compiling the standalone script absolutely required that explicit main declaration to satisfy the compiler's need for a defined entry point, will that hard requirement still hold true when we are working interactively inside GHCI?
What changes in that environment that might allow GHCI to accept a raw expression like default main, where the static GHC compiler failed? Considering Haskell is a strongly typed declarative language, understanding the difference in how these 2 environments process top-level statements, that is critical to truly mastering the language.
That is your next level of exploration.